property of an electron is that it is a negatively charged particle, which we saw from the experiment which was performed by J.J. Thomson, where the cathode rays or the electrons were attracted towards the positive electric field and were repelled by the negative electric field. Now the second point is it carries a negative charge of -1. Now this negative charge of -1 is considered to be the basic unit of an electric charge. The mass of electron, which was also given by J.J. Thomson, is 9.11 into 10 to the power minus 31 kg. Now this particular mass is very less, that is 1 by 1840 of the mass of an atom of hydrogen. This mass is considered to be massless because it's very light or very small mass. Okay. Moving on to the discovery of protons. Now how these protons were discovered? Atom is considered to be electrically neutral. Molecule is also electrically neutral. Now the question arises, which are the particles that have this charge in them? Now this one you have to keep in mind that the ions are the only particles which have, this is the most important thing. So therefore, if the atom contains negatively charged particles, which we saw in the experiment which was performed by J.J. Thomson, that are electrons, it must contain positively charged particles also. Then only that negative charge can be cancelled by the positive charge and we can declare an atom to be electrically neutral. Okay. So the search for those positively charged particles led to some more experiments which was performed by the German scientist Eugen Goldstein. Okay. So in 1886 Goldstein worked with a modified discharge tube. Okay. So the discharge tube which was used earlier by William Crookes, then it was again little bit modified and it was used by J.J. Thomson. Now this Goldstein, what he did, he modified that discharge tube again. Okay, what were the modification? Let's see. With a modified discharge tube provided with a perforated cathode. Now what was the modification that Goldstein did? He had made the cathode perforated, okay, with extremely small holes. When a large electric field was applied between the electrodes, he observed not only the electrons emitted by the cathode but also some luminous rays in the region behind the cathode. So what was the observation that Goldstein had? He saw that when he applied a large electric field or very high voltage, he saw that rays were emitted from the cathode, but this time rays were getting emitted from cathode, but there were certain luminous rays also which he saw behind the cathode, and these rays he named as canal rays or positive rays as they contained positively charged particles. Now these positively charged particles were later called protons. Okay, up to this much it is clear. So what did Goldstein did? He modified the discharge tube and made the cathode little perforated with extremely small holes, and then he applied a very high voltage power. Okay, when he applied a very high voltage power, what he observed, that electrons were emitted by cathode as it was seen by the experiment which was performed by William Crookes and J.J. Thomson. Same thing happened, but what was the additional thing that he saw? He saw that some luminous rays were emitted just behind the cathode. Okay, so these rays which were emitted from the cathode, he called those rays as canal rays or positive rays. Later those canal rays or the positive rays were named as protons. So this was all about the discovery of protons. Moving on to the properties of protons. So a proton is a positively charged particle which we got from the experiment. It has a positive charge which is equal in magnitude to that of electron, and that is why we can call the atom as electrically neutral, because they have the same magnitude, therefore they can cancel each other. Okay, what does magnitude means? Okay, this is the question for you. You will answer me, what is a magnitude? Okay, let me tell you how does a positive charge cancels a negative charge. Suppose if you have 5 positive charge, okay, so what is the magnitude? 5. And you have 5 negative charge. Okay, so according to the second point, a positive charge equals in magnitude to the that of an electron. So 5 positive charge are present if then a particular atom also has 5 negative charge, and therefore they can cancel each other, and we can declare an atom as electrically neutral. Clear? Moving on to the third point, the mass of proton is equal to that of hydrogen. So what is the mass of proton? Mass of proton is equal to that of hydrogen. But what was the mass of electron? It was slightly less than that of hydrogen, which with this we can derive a conclusion that proton is little heavier than that of electron. Thomson's model of the atom. Now, Dalton's atomic theory suggested that atoms are indivisible and indestructible, but the discovery of 2 fundamental particles, that are electrons and protons, inside the atom led to the failure of this aspect of the theory, and it was considered necessary to know how the electrons and protons are arranged within the atom. And the first person who took the initiative was J.J. Thomson. So basically, in the beginning what happened, through the experiment which was performed by William Crookes and J.J. Thomson, we came to know about the subatomic particles which are present inside the atom, that are the protons and the electrons. Now, we knew what are the particles which are present, but there was another question arising, that how these particular subatomic particles are arranged inside an atom. So, the next thing that need to be discovered was their arrangement, and as I told you, the first initiative was taken by J.J. Thomson. So what he did, he proposed the model for the arrangement of these electrons and protons, and he called his arrangement as Plum pudding model. So the left hand side you can see the plum pudding, and this is the model which Thomson gave, which is on the right hand side. Now basically, plum pudding is a plum in which pudding of any variety, whichever flavor is available, are embedded on the pudding. So these are the plum. Likewise, Thomson also said that there is a pudding of positive charge in which the negative charges play the role of plum. Now here, if you take this one pudding, these red color are the electrons. Say these are the electrons which are present in the form of plum. Okay. Now the plum pudding model was created after J.J. Thomson's work with cathode ray led to the discovery of electrons. The model disapproved a part of Dalton's theory on the atom, since it proved that there was a particle smaller than an atom which was known as electron. Now the plum pudding model is basically a negatively charged electron in a puddle of positively charged. So this is a puddle of positively charged in which these are the electrons which are present in the form of plum, which are embedded in the pudding. Okay. This is also another explanation. For a detailed explanation, I have done this one. So Thomson proposed the plum pudding model of the atom in the year 1904. Now, according to this model, atom is a sphere of positive charge and the electrons are spread out inside it like plum in a spherical puddling. So this is a spherical puddling of positive charge, and here these red colors are the plum of negative charges, and this plum are actually the electrons as per the plum pudding model. Okay, the atom has an equal number of positive charges, that is the protons, and negatively charges, that is the electrons. So the atom as a whole is electrically neutral. Now the Plum pudding model was later found to be incorrect when Rutherford proposed his atomic model. Now there are basically two things. First is atomic theory and the other is atomic model. Atomic theory deals with the electrons and protons, the basic subatomic particles. Atomic model deals with how these electrons and protons are arranged in an atom. Alpha scattering experiment. In 1911, Ernest Rutherford, a New Zealand-born British physicist, conducted an experiment in order to find the arrangement of electrons and protons in an atom. Now the picture which is displayed on your screen right now, we will go through the detailed explanation. In the left side you can see the experiment which was performed by Rutherford, and the right side is the observation and conclusion that Rutherford gave. Okay. Now in this experiment, a fast moving alpha particle which was discovered by Rutherford in 1989 were made to strike a thin gold foil. Okay, it was very thin. You can see that in the figure. Okay, now the question arises, what is an alpha particle? Now alpha particles are positively charged particles identified as helium nuclei. Okay, and they contain 2 protons and 2 neutrons. So this is for your basic knowledge that what is actually an alpha particle. Okay, so when he did this experiment, what was the observation? Most of the alpha particles pass through the foil without any deflection. You can see this one. They pass through the foil without any deflection. Some alpha particles were sharply deflected at different angles. You can see some are sharply deflected at different angles after passing through the foil, and a few of the particles turn back, okay, directly on their original path. So this was the observation that Rutherford got when he did the gold foil experiment. Okay, so this is the source of radioactive from where these alpha particles were emitted. This is the gold foil which Rutherford used. Okay, and these are the alpha particles. Okay, so this is also, you can see the same thing here. What is the whole thing? This is the source of the alpha particles. Okay, beam of the particles. Some are getting directly through the gold foil, some are getting deflected at different angles, and some rays, rare, okay, they are just turned back and directed on their original path. Okay, positively charged particles were aimed at atoms of gold. These are the atoms of the gold. If you see in the microish view, this is what you get. Okay, now what is the conclusion that he got on the basis of the above observation? Rutherford in 1911 made the following observations which we are going to discuss right now. Okay, now most of the alpha particles passed straight through the foil, which suggested that atoms consist of lot of empty spaces inside it. So these are the empty spaces which are present in between the atoms of gold, okay, or atoms of, actually he used gold, so therefore we are focusing on the gold atoms only, okay. Now some of the alpha particles were deflected from their path at different angles. You can see these two rays are getting deflected at different angles, which suggested that atoms have a tiny but heavy positively charged core that repels positively charged alpha particles. Okay, because of these positively charged particles which is present at the center of the nucleus, the alpha particles which are also positively charged, that is getting reflected, which means positive will repel positive and therefore they are getting deflected at different angles. Okay, now the mass of the atom is concentrated in this tiny center core. So what is the other conclusion? That the mass of the atom is concentrated in the tiny center core, which Rutherford called as nucleus. So this one he called as nucleus, which is the center of mass, which is also positively charged, and this is only responsible for the deflected alpha particles. Okay. Now, as a result of this experiment, the Plum pudding model was replaced by the nuclear model of the atom. Okay, so we will go through the Rutherford's nuclear model of the atom. Now, with this experiment, he came to a conclusion that there is a nucleus which is present in the center and the mass is also present there and it is positively charged. Okay, so this helped him to understand or to give us a clear idea about the nucleus, and he gave his experiment another view and he described the structure of the atom through his nuclear model of the atom experiment, or you can say as theory. Now moving on to Rutherford's nuclear model. Now on the basis of his experiment which he performed through the gold foil, Rutherford put forward the nuclear model of the atom. The model described the structure of the atom. Okay, so what he said through his model, there is a positively charged core in the center of the atom. Okay, so there is a positively charged core at the center of the atom which he called as nucleus. Clear? And nearly all the mass of the atom is concentrated here. Where? Here in the nucleus. The electrons revolve around the nucleus. Okay, how? Like planets revolving around the sun. Okay, these electrons are revolving around the nucleus in well defined circular paths. These circular paths are called as orbits, okay, like planets which revolve around the sun, and hence this model is also called the planetary model of the atom. Okay, now since the atom is neutral, the number of electrons, which is the negatively charged particle, is equal to the number of protons, that is the positively charged particles in the nucleus, and hence they can cancel each other and we can say atom is electrically neutral. This was all about the Rutherford's nuclear model of the atom. Now with all these experiments we came to know about the subatomic particles, that are protons, electrons. Okay, till now we have not got an idea of what are neutrons, okay, but we have got the idea of nucleus and what it constitutes, where is mass, and how these electrons are arranged. Now the thing came one more question arised, that how are these electrons arranged? Okay, there are not one electrons or two electrons. The number of protons are present, the same magnitude electrons are present. Now the question arises, how are these electrons arranged? So Bohr came with his model. Okay, and what was the model which Bohr proposed? That was known as Bohr's atomic model. Okay, who was Bohr? Now the Danish physicist Niels Bohr further developed Rutherfords model. Okay, and in 1913 he proposed his atomic model. Now in the Bohr model of the atom, electrons travel in definite circular orbits around the nucleus. The orbits are labeled by an integer, the quantum number n. Electrons can jump from one orbit to another by emitting or absorbing energy. Okay, this you will understand. According to Rutherford, nucleus is here, okay, which is positively charged, and electrons are revolving around. This was what? These are the electrons. Okay, this was what Rutherford said. Now Bohr, what he said, that electrons are revolving around the nucleus in a particular orbits, and he named those orbits as shell and labeled those shell as K, L, M, N. Okay, starting from the innermost cell. The innermost cell he named as K, this one, then L, M, N. Okay, this was K, then L, then M, then N. From the innermost shell he started naming. Okay, so this was, who did this? Bohr did this. Okay, each orbit or shell is associated with a fixed or definite amount of energy. Now the K cell has a definite amount of energy, L has a definite amount of energy, M has a definite amount of energy, and N has a definite amount of energy. Okay, hence these shells are called energy levels. Since they have a fixed or definite amount of energy, these shells are known as energy levels. And the energy associated with energy levels increases as we go further away from the nucleus. Now this is the nucleus. This is the nucleus. As we go away, the energy increases. Like K's energy is less than L, which is less than M, which is less than N. Okay, so the lowest energy is of K and it increases this way. So this was what Bohr said. So here in this image, same thing is displayed. First is K cell, then L, M and N, and here this one is a positively charged. Now numbering starts from the innermost cell, 1, 2, 3, 4 and so on. Okay, here this is for your understanding, that in Bohr model the position of electrons around the nucleus is analogous to the steps of the stairs. Okay, these are the steps. So this is the K cell, then comes M, K, L, M, N. Okay, like this the stairs goes on. Now stairs steps are quantized. They only have certain places where person may stand. Now electrons may be present in this cell only, and then number 2 cell, or you can say L cell, number 3 or M cell and N cell. Electrons cannot be present in these empty spaces. Okay, like you cannot stand in the in between the stairs. Likewise, electrons cannot be present in the empty spaces. They will be only present in these orbits or these shells which are present. Okay, and each shell has their own energy, and the lowest energy is with K cell and it increases away from the nucleus. This was about the Bohr's atomic model. Now then comes the discovery of neutrons. Rutherford concluded that virtually all of the mass of an atom is concentrated in its nucleus, which was given by Rutherford. Now, since electrons have a negligible mass, it is believed that the entire mass of the atom was because of the mass of the proton which is present in the nucleus. As I have told you, because the mass of the proton is equal to that of hydrogen, which we have discussed earlier, and electrons has slightly less than that of the mass of hydrogen. Now, Rutherford found that except for hydrogen atom, the atomic mass of other elements were more than the total mass of protons present in them. Now, till hydrogen it was okay. We concluded that okay, hydrogen atom, the whole mass is concentrated in the center, which is occupied by the protons. But as we went towards the other atoms, we saw that the atomic mass of other elements was much more than the total mass of the protons present in them, which gave a hint that there are certain other elements also present whose mass is getting added and the atomic mass is showing a little bit fluctuation, and it is not matching with that of the protons. So therefore, in 1920 what happened? Rutherford predicted the presence of another subatomic particle in the nucleus of the atom. Okay. Now, in 1932, James Chadwick, an English physicist, discovered the subatomic particle called neutron. Okay. So who was the one who discovered neutrons? James Chadwick discovered neutrons, for which he received the Nobel Prize for Physics in 1935, and he found that the particle had no electric charge and has only mass in it, which was adding to the atomic mass, and there was fluctuation in the atomic mass and the total mass of the proton. Okay. The neutron didn't had any charge and the mass was approximately equal to that of proton. Properties of neutrons. Neutrons are present in the nucleus of an atom along with the protons, and the atoms of all elements contain neutrons except that of hydrogen atom. Now, hydrogen atom doesn't have neutrons, except that all other elements have neutrons. This is an important thing, you have to remember this one. Okay. What is the first property? A neutron carries no charge. A neutron carries no charge. The mass of neutron is slightly greater than the mass of proton, and the mass of neutron is 1.675 into 10 to the power minus 27 kg. So the mass of the neutron is slightly greater than proton. So if you see whose mass is greater, neutron, then comes proton, and then comes electron, if we arrange according to the mass. Okay, so what was the speciality of neutron? That it doesn't add any charge, but it was adding, but it has certain mass which was greater than proton, which was,
as I have told you before starting the video, now the time has come for the bonus step. I have linked a document down in the description box below. Please go and check and also try to solve them, because it will help you to get thorough with the entire content that we have discussed. There is another smart tip for you. You will find another link just below the previous one, which will help you to recap all that we have learned today in a better and smart way. So that's all for today. Hope you liked the video and was also knowledgeable. After watching the video, please go through your textbook for thorough understanding. Signing out for today. Thank you for watching.